At the bottom right, change to kilonewton meter. Click File, New Model, and press No. For this, you'll see 4466. Number of stories 4. Typical story height changes to 3.5. Bottom story height changes to 2.5. Click OK. This is what you get. Now, on the top, File, Edit, View, Define, Assign. Go to Define and then click Material Properties. Select Concrete, click OK, and then again go to Define, Frame Section, and select First Property, and from there click and drag down all the way down, then delete and click Add Rectangular. Here write the section name, that is we are defining beam of 230 into 450 mm thickness, so accordingly write the section name. Change the material to concrete, then depth of 0.45 meter, that is 450 mm, width of 0.23, click reinforcement, tick beam, provide 30 mm cover, that is 0.03, then click OK, OK, OK. Then again define frame section and go to add rectangular, write the section name. Right now we are defining column of 230 into 450. Similarly, change the material to concrete, depth of 0.45 and width of 0.23. Click reinforcement, see column, and provide 30 mm cover, that is 0.03, and bar size of 16D. Search for 16D, click 16D. Column bar size, that is also 16D. After that, OK, OK, OK. Define wall slab deck section. Select slab 1, click OK, and then with this, now you have to go to first floor, click 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 first floor. Now with this draw line option, we are going to draw column, so change this to column, click, then select the whole thing. Now this thing has been assigned to column, and with this set building view option, uncheck the column, OK. Again with the draw line, select here, we are drawing beam, so already it's beam, select, now it has been assigned to beam, click OK. Now select the boundary wall of the beam, all the sides. After this, go to assign and frame line loads, click distributed loads. After calculation, the dead load will be 14.4 something, click OK. Add to existing, click OK. Now with the rectangular option, select slab 1, close, and from top left to right bottom, select the area. With view option, object fill, click OK. You can see the slab. Select the slab, assign, cell area load, uniform, dead load, load for dead load 1 kilonewton, add to existing, click OK. Again click the slab, assign, cell area loads, uniform, and now live load 3, add, select the whole area, cell area, go to slab, OK, and diaphragm is select. Go to 3D view, you can see diaphragm. Now go to plan, click OK. Go to base floor and then select everything and go to assign, go to joint point, and then rest and supports, and click fix supports, click OK. In 3D view you can see supports have been provided. Now go to plan, story 1. Now we are going to replicate. So for that, go to set building view options. Here you have to check columns, beam, object fill, everything you have drawn of this. Click OK. Now see in 3D view everything has been selected. Plan, go to story 1, select everything. After select, click edit, go to replicate and go to story, click option. Here you have to uncheck restrain, everything remains same. Click OK, and you have to replicate for story 2 and 3. Click OK, and you can see it has been replicated. Here in 3D view you can see from story 1 to story 2 3 it has been replicated. Now go to plan, go to story 3, click OK. Now with select option, select entire, then go to edit, replicate and story, and go to option 4. Here you have to uncheck distributed loads and undistributed loads, others remain same. What you need to replicate from story 3 to story 4, click OK. Now replicate to story 4, click OK. Now you can see 3D story 3 has been replicated to story 4. Now click story 4, and for story 4 now we are going to provide load on the 4th floor. There won't be any beam or column loading, so only slab load will be there. So click the slab, assigned, go to cell area load, uniform, and provide live load, which will be a very small load, that is 1.5. and again you have to provide dead load. Again click the slab, go to assign, cell area load, and dead load, and dead load is 1 kilonewton meter. Add to existing and click. Now with select option, select the boundary wall, all 4 sides. This is on the 4th floor. We are going to provide loading on the parapet wall, as there's only loading of parapet. So of this, go to assign and joint load, distributed, and load is 3.3, which you have calculated, that is 18 into 0.23 into height of parapet wall. Usually it is 80 centimeter. Click OK. Now we're going to provide diaphragm, so select all, go to assign, cell area, click diaphragm and click OK. You can see the diaphragm in 3D view. You can see all the diaphragms provided in all floors. Now we are done with everything. Now go to analyze, set analysis option. Here always you have to check for dynamic analysis. Click OK. Again go to analyze, check model, tick all the check boxes from starting to till the end. Check all the tick boxes, then click OK. Here no messages warning, so you have done the right thing. So now again go to analyze, then run analysis and save the design with your file name. Save anything suitable name for your design of residential building. Click save. After that you can see the deflection curve of the whole building, and you can see the animation. After doing all this, now you have to analyze. Near to that flash option to the left, you can see this option, drop down, and you can see the support reaction at each section. And for the shear force, go to shear 22, click OK. You can see the shear force diagram, and particularly for any section you can click left and then right click, and this dialog box will pop up. And here for scroll for values, you can scroll at any point of the section and you can find individual shear. Click OK. Again, go to the same option, click frame in that one, and moment 33, click OK. Again, left click, select, and then right click. You can see the bending moment. Scroll for values, you can scroll for any point and you can find the bending moment. And that's it. Now we have designed the residential building in ETABS. Thank you for watching.